Welcome to a deep dive into the world of AI. Today we're going to be exploring how AI models are learning to see the world, not through images like you might think, but through the power of language.
It is really remarkable we're moving beyond that traditional method of feeding AI millions of labeled images and instead harnessing the power of language to teach these models visual concepts.
Exactly. And we're diving deep into a research paper today called Learning Transferable Visual Models from Natural Language Supervision. And this paper is packed with some serious aha moments. Like, for example, did you know that researchers have created an AI model that can achieve accuracy on ImageNet that's comparable to traditionally trained models?
Yes, and the truly astounding part is that this model achieves this impressive accuracy without ever actually seeing any of the ImageNet training
It's
images.
like learning to identify different types of birds just by reading about them in a book. You've never actually seen them in real life, but you can still pick them out in a photo.
That's a great analogy. The model is called CLIP, which stands for Contrastive Language-Image Pre-training, and it learns by being fed a massive data set of text and image pairs. So imagine showing the AI a picture of a dog and then giving it the caption, "a furry, four-legged friend wagging its tail."
So it's like we're creating a visual dictionary for the AI, linking words with images.
Mm,
But what really grabbed my attention is this concept of zero-shot learning.
yeah.
Can you explain what that is and why it's such a game changer?
Zero-shot learning is the ability of a model to perform a task without specific training on that task's dataset. So think of it like this CLIP can classify images from a variety of datasets without ever being explicitly trained on them.
Well then, so you're telling me that CLIP can identify a cat in a photo, even if it's never been shown a picture of a cat before, simply because it understands the concept of a cat from the language it's learned.
That's exactly right. And what makes this so groundbreaking is that it opens up a world of possibilities for using AI in situations where labeled data is scarce or expensive to obtain. Like, imagine training medical AI models on textbooks and research papers without needing a massive labeled data set of medical images.
Wow, that's incredible. It completely changes how I think about training data and the potential of AI in so many fields. But the paper also mentions something called prompt engineering, which sounds pretty intriguing. It's like we're not just handing CLIP a dictionary, but teaching it how to think about those images in different ways based on how we talk to it.
Yes, prompt engineering involves crafting the instructions or the prompts given to CLIP, and the way you phrase the task can significantly impact the model's performance.
So instead of just asking CLIP to identify a bird in a photograph, could we give it a more descriptive prompt like a feathered creature perched on a branch? And would that lead to a more accurate identification?
Yes, precisely, using more nuanced prompts can lead to better results. Researchers found that prompts like a photo of a big label or a photo of a small label often outperform a simple label prompt.
It's like teaching a child to recognize objects by describing their characteristics. We're not just telling them, this is a ball. We're saying, this is a round, bouncy object you can throw and catch.
That's another great analogy, and what's especially clever is that once the text embeddings for these prompts are cached, you can combine multiple prompts without much additional computational cost. It's like getting a free performance boost just by being creative with your language.
Okay, this is getting really exciting. It seems like the way we communicate with AI is becoming just as important as the data we feed it. We're not just training models, we're having conversations with them. But I'm curious, how does CLIP handle different types of images? Does it break down when it encounters something outside of its training experience?
This is actually where CLIK truly shines. It's much more robust to distribution shifts than models trained solely on ImageNet.
Wait, distribution shifts. Could you explain what that means? It sounds like something went wrong in the AI matrix.
Imagine a model trained solely on photos of cats and dogs. If you suddenly showed it a picture of a bird, it might struggle because it's encountering an image that is outside of its training distribution.
Okay, so it's like taking a city kid to a farm for the first time. They've never seen a cow in real life, so they might not know what to make of it.
Exactly. Traditional ImageNet models often exhibit this type of brittleness. They excel on ImageNet, but struggle on other data sets. And this difference in performance is known as the robustness gap.
So you're saying CLIP doesn't fall into that trap. It can handle those farm animals, so to speak.
That's right. CLIP generalizes much better to different types of images and data sets. And what's fascinating is that this robustness seems to stem from the way it's trained with language, not just the size of the data set it's learned from.
So CLIP is not only smart, but it's also incredibly adaptable, all thanks to the power of language. It's like learning to appreciate different cultures through their literature and stories. You develop a deeper understanding and appreciation for the world's diversity.
I like that comparison. It highlights how CLIP's approach allows it to develop a more comprehensive and flexible understanding of the visual world. But this raises a fascinating question. How does CLIP's learning process compare to our own? How do humans and AI learn differently?
Oh, that's a great question. Tell me, who learns faster, human or machine?
Well, it's not a simple answer. The researchers conducted a study on pet breed classification to compare how CLIP learns to how humans learn, and what they found was that humans are much more data-efficient learners.
You mean we can still outsmart AI, at least when it comes to learning new things? Quickly give me the details.
In the study, humans were able to achieve a significant jump in accuracy after seeing just one example of each pet breed. CLIP, on the other hand, still required much more data to achieve similar results.
Wow, so we humans can quickly absorb new information and update our understanding based on just a few examples. It's like seeing a new type of fruit for the first time and instantly knowing it's a fruit, even if you don't know its exact name or variety. CLIP still needs to see a lot more examples before it reaches that level of understanding.
Exactly. It highlights the incredible efficiency and flexibility of the human brain, something that we are still striving to replicate in AI systems. And it also points to a crucial area for future AI research, bridging the gap between human and machine learning.
I'm definitely sensing a theme here. Language is key, but
Yeah.
before we get too carried away with all the amazing things CLIP can do, I'm guessing it's not perfect. Are there any limitations to this approach?
You're absolutely right. While CLIP can handle many natural image distributions, it struggles with data that is truly outside of its training experience.
So, if CLIP has never encountered a handwritten letter before, would it be able to recognize it as a letter, or would it think it was some abstract art?
That's a great example. Researchers found that CLIP performs quite poorly on MNIST, a data set of handwritten digits. This suggests that CLIP's robustness comes from its vast training data, almost like it's trying to make everything familiar by covering a vast range of possibilities, but as MNIST shows, there are still limits to this approach.
It seems like CLIP doesn't fundamentally solve the issue of brittleness in deep learning. It's more like it's trying to outsmart the problem by creating a massive safety net of data.
Precisely. And there are other areas for improvement. For instance, CLIP's output space is more limited compared to, say, an image captioning model.
So CLIP can classify images, but it can't generate creative descriptions like those fancy image captioning models that can write poems about a sunset. It's more of a pragmatist than a poet.
Exactly. There's a lot of potential for future research to combine the strengths of both approaches, creating AI models that can both classify and describe the world around us with fluency and nuance.
Well, that's a fascinating idea. A world where AI can not only recognize a flower, but also write a haiku about its delicate beauty. Amazing. All right, before we move on to even more fascinating aspects of CLIP, let's take a short break. When we come back, we'll dive deeper into CLIP's performance on specific tasks and data sets and explore those fascinating comparisons to human learning in more detail. Stay with us.
Welcome back. Before we took a pause, we were discussing CLIP's impressive robustness and how it stacks up against traditional models to really grasp this. Let's dive into some specific examples.
Yes, I love concrete examples. The paper highlights CLIP's performance on a collection of natural distribution shift datasets. What are these datasets all about, and why are they particularly challenging for AI models?
These datasets represent real-world situations where images differ significantly from the carefully curated world of ImageNet data. For instance, there's ImageNet A, specifically designed to fool ImageNet trained models. Then we have ObjectNet, which presents objects in unusual positions and contexts, making recognition trickier. And finally, there's ImageNet R, which uses artistic renditions of those ImageNet classes.
So these datasets are like obstacle courses for AI models, testing their ability to think outside the box, so to speak.
Exactly. They assess whether the AI can generalize its knowledge beyond textbook examples, and the results are truly fascinating. CLIP consistently outperforms traditional ImageNet models on these challenging datasets. It achieves a much higher accuracy under these distribution shifts.
This is where I really start to see the power of language training coming into play. It's like
Yeah.
CLIP has developed a more intuitive understanding of what it's seeing, allowing it to navigate these tricky situations.
That's a great way to put it. The researchers even pitted CLIP against a model that had been fine-tuned on the ImageNet dataset. While fine-tuning improved the model's accuracy on ImageNet, it surprisingly reduced its average robustness on those other datasets.
Hold on, you're telling me that by adapting to the very specific world of ImageNet, the model actually became less adaptable overall?
That's precisely what the research shows. It seems that over-optimizing for a specific dataset can sometimes backfire. It leads to a decrease in the model's ability to generalize the cults. This highlights a key takeaway from the paper's zero-shot CLIP models are much more representative of a model's true capability.
That's a fascinating insight. It makes you wonder if we as a field have been overly focused on benchmarks like ImageNet and perhaps haven't paid enough attention to building models that can handle the complexities and surprises of the real world.
It's a valid point. CLIP's success certainly challenges the conventional wisdom in computer vision. It suggests that natural language supervision might be a more robust and generalizable approach. It's a bit like teaching someone the fundamental principles of physics rather than just giving them a formula sheet to memorize.
I see what you mean. If you understand the underlying concepts, you can adapt and solve problems in a variety of situations, even if you've never encountered that specific problem before.
Precisely. Now remember that intriguing study we touched on earlier, the one comparing CLIP to humans in the pet breed classification task. Let's dig a little deeper into those findings. What else did the researchers uncover about the differences in how humans and AI learn?
Yes, I'm really curious to hear more about that. Who reigns supreme in the learning arena, human or machine?
Well, what's fascinating is that humans demonstrate a much greater awareness of their own limitations. In the zero-shot scenario, humans could often identify when they didn't know the breed, while CLIP confidently assigned probabilities across all the classes even when incorrect.
So humans were more comfortable admitting, I don't know, while CLIP was a bit overconfident, perhaps even a bit of a know-it-all.
You could say that, and when the humans were shown just one example of each breed, their accuracy skyrocketed, mainly because they could now correctly classify images they had previously been unsure about.
That's remarkable. Humans can quickly update their knowledge based on just a single example. CLIP, however, still required a much larger dataset to achieve a similar level of accuracy. It really speaks to the incredible efficiency of human learning.
It truly is remarkable how quickly a child, for example, can learn a new word or concept after just one or two exposures. We're still a long way from replicating that level of learning efficiency in AI systems.
It's both inspiring and a little humbling, isn't it? We've created these incredibly complex AI models,
Hmm.
but the human brain still holds the gold standard when it comes to learning and adaptation.
Absolutely. And this leads us to an area where CLIP still faces limitations, data efficiency. It relies on a massive data set to achieve those impressive results. If we could unlock the secrets of human-like learning efficiency in AI, imagine the potential.
It would be a game changer. Think of the applications in medicine, education,
Mhm.
robotics. The possibilities are endless. But for now, let's shift gears and talk about CLIP's performance in a specific area that I find particularly fascinating, and that is its ability to understand abstract concepts. Tell me, how does CLIP handle abstract art?
That's a great question. Remember how we talked about those distribution shifts earlier? Well, abstract art is a prime example of a distribution shift. It's a visual language that often departs from the literal representation of objects and scenes that we see in data sets like ImageNet.
Exactly. It's about emotions, ideas, and interpretations, rather than just depicting a recognizable object.
Mhm.
So how does an AI model like CLIP, which is trained on real-world images and text, make sense of something as open-ended as abstract art?
Well, CLIP's strength lies in its ability to connect language with visual concepts. Even those that are highly abstract researchers have found that CLIP can perform surprisingly well on tasks related to abstract art, such as classifying paintings by style or identifying the emotions they evoke.
That's incredible. It's like CLIP is learning to read the emotions and ideas embedded in the brushstrokes and colors, just like an art critic might.
That's a great way to put it. CLIP's ability to process language allows it to go beyond simply recognizing objects. It can tap into the deeper meanings and interpretations associated with visual forms.
This opens up a whole new world of possibilities for how we can use AI in creative fields. Imagine using CLIP to analyze the emotional impact of a film sequence, or to generate personalized art recommendations based on your individual preferences.
Exactly. CLIP's ability to bridge the gap between language and visual abstraction has the potential to revolutionize how we interact with art and creativity.
I'm definitely going to be keeping an eye on this area of research. It's truly fascinating to see how AI is expanding its capabilities beyond the realm of concrete objects and venturing into the world of human emotions and artistic expression. But for now, let's take another short pause when we return. I'm eager to delve deeper into the potential implications of language-powered AI and what it might mean for the future of our relationship with technology. Don't go anywhere. Welcome back to our deep dive into CLIP, the AI model that's changing how we think about computer vision. We've explored CLIP's amazing abilities and delved into its unique approach to learning. Now, I want to step back and consider the bigger picture. What does CLIP's success tell us about the future of AI and its relationship with language?
Well, CLIP's effectiveness really points towards a future where language takes center stage in how we build and interact with AI. We're moving beyond simply training models on labeled data. And natural language supervision opens up a whole new dimension, allowing these models to learn from the vast amount of information encoded in human language, even code.
So it's not just about giving AI a dictionary. It's about tapping into that incredible richness and complexity of human language to build more adaptable and intelligent systems.
Precisely, language is our primary tool for communicating knowledge concepts and ideas. And by training AI models on language, we're essentially giving them access to the collective wisdom and understanding of humanity.
That's a pretty powerful thought. It makes you wonder what other breakthroughs are possible when we truly unlock the potential of language-powered AI.
The possibilities are truly exciting. Imagine AI systems that can learn new skills just by reading instructions, or that can generate creative text formats like poems or code based on a simple prompt. We're already seeing glimpses of this potential with large language models like GPT-3.
It's like we're handing AI the keys to the human knowledge vault. It's exhilarating and maybe a little daunting at the same time.
I agree. As AI systems become more sophisticated and integrated into our lives, we need to carefully consider the implications. What are the long-term societal and ethical considerations we need to address as we venture further into this uncharted territory?
That's a crucial question. How do we ensure that these powerful AI systems are aligned with human values? How do we prevent them from being misused or causing unintended harm? These are discussions we need to have as a society.
Absolutely. We need to engage in thoughtful and open dialogues involving ethicists, policymakers, and the public. These conversations need to happen now as AI rapidly advances.
Okay, before we wrap up our deep dive, I want to revisit that key takeaway that blew my mind at the very beginning. CLIP can achieve ImageNet level accuracy without ever seeing those ImageNet training images. What does this tell us about the limitations of traditional training methods, and what exciting new possibilities does it open up?
CLIP's success challenges the traditional assumption that AI models need to be trained on massive, carefully labeled datasets. It suggests that we can leverage alternative sources of supervision, like natural language, and achieve comparable or even superior performance.
So we're not limited to the show and tell method of training. We can teach AI through language, concepts, and ideas.
Exactly. And this is a game changer for fields where labeled data is scarce or expensive to collect. Think about training medical AI models on textbooks and research papers, or teaching robots new tasks with verbal instructions.
It's like we're transitioning from a data-centric approach to a knowledge-centric approach to AI.
That's a great way to put it. This shift could usher in a whole new wave of AI innovation, leading to more adaptable, intelligent, and human-centered technologies.
It's incredibly exciting to consider the possibilities. So as we conclude this deep dive, I want to leave our listeners with a question to ponder. If AI can learn so much from language alone, what are the broader implications for how we interact with technology, how we educate future generations, and how we shape the future of our world? It's something to think about as AI continues to evolve at such a rapid pace.
It's a profound question that invites us to reflect on the evolving relationship between humans and machines. As AI becomes more proficient with language, these systems will increasingly participate in our conversations, collaborate with us on creative projects, and maybe even challenge our understanding of what it means to be intelligent.
It's an exciting and perhaps even a little unsettling prospect. But one thing is certain, the future of AI is deeply intertwined with the power of language.
And as we venture into this uncharted territory, we must do so with a sense of wonder, a commitment to ethical development, and a willingness to engage in open and honest conversations about the implications of these powerful new technologies.
Thank you for joining us on this journey into the fascinating world of CLIP. We hope this deep dive has given you new insights and sparked your curiosity about the future of AI and the power of language. Until next time, keep exploring, keep questioning, and keep pushing the boundaries of what's possible.